Welcome to solverfy.
We're given a weighted graph, and we're asked to find the maximum spanning tree for this graph. The weighted graph is the one in exercise 3. If you look in the book, you see that this is a graph on vertices A, B, C, D, E, F, G, H, I with weighted edges. And to find a maximum spanning tree for this graph, we're going to use a modified version of Kruskal's algorithm, which we derived in an earlier exercise. So, the first step of Kruskal's algorithm is to start with the graph that contains only the vertices and no edges of our given graph. So first I'm just going to draw the vertices A, B, C, D, E, F, J, G, H, and I. In the next step, I'm going to find the edge with the largest weight in the given graph. This is 8, and it occurs between D and H. So I'll add the edge DH. In the next step, find in the remaining graph the edge with the largest weight. This is 7, and it occurs between D and E. So I'll add this edge to our graph so that it does not create a circuit. In the next step, I'll find the edge with the largest weight in the remaining graph. This is now 6, and this occurs between D and G and between B and F. So first consider DG. If we are to add edge DG, this will not create a circuit, so this is perfectly valid. And if we are to add the edge EF, we also won't create a circuit there, so that's also valid. I'm sorry, B and F, my mistake. But if we draw an edge between B and F, we won't create a circuit, so it's valid. In the next step, in the remaining graph, we find the largest weight is 5 and occurs between A and B and between B and E. So if we add the edge AB, we don't create a circuit, so it's valid. And if we add the edge BE, we don't create a circuit, and so this is valid. And finally, notice that there are still 2 vertices which are disconnected from the graph, C and I. So the edge with the largest weight incident to C and the edge with the largest weight incident to I, these both have weight 4. And so we'll add those edges. So we have that BC has weight 4. If we add this edge, don't create a circuit. And we have that edge FI has a weight of 4. And if we add this edge, we still don't create a circuit. But now we have a connected graph. And so the algorithm terminates, and by a modified version of Kruskal's algorithm, it follows that the resulting graph is a maximum spanning tree. With edges AB, BC, BE, BF, DE, DG, DH, and